to Eyes on Enterprise, where I bring in Googlers to talk about the technology landscapes that are shaping how enterprises adapt, modernize, and scale. I'm Stephanie Wong, and today I'm bringing back on Brian Dorsey. He is a developer advocate for compute, and we're going to be talking about how you should rethink your VMs, which I'm excited to hear about because I'm unsure of what you actually mean by that.
Excellent. Let's do it.
Yeah. So, okay, let's start by examining our assumptions about VMs. Like, what are some of those assumptions? To me, a VM is a virtual computer. You have CPU, memory, disks, networking. What else is different here?
Yes, that's exactly it. It's relevant, though, is that it's the base of many, many of our other services. It is super common in architectures. Everybody's running some VMs. But if you're only thinking about it as kind of a classic VM, you might be leaving kind of time and money on the table.
Oh, time and money. That's like everyone's top of mind, right?
Yep.
Okay, interested in hearing more. But I mean, as I imagine, don't Google Cloud VMs typically fit in that model?
So at a high level, yes. It is an abstraction of this CPU, network, disk, RAM. But we're used to thinking of that as kind of a slice of one computer. And it's really a slice of resources that are across the whole data center. So that enables a whole bunch of agility and reliability that you wouldn't get, you wouldn't notice otherwise, or you might not get.
I imagine this is the basis of what you mean by rethinking VMs, slice of a data center.
Yeah.
So can you kind of dive into more about how that's truly different than thinking otherwise?
So like an example of that is, when you buy a computer, it's a kind of a big decision. You buy it and you have it for 3 to 5 years or whatever, and like you're stuck with that shape. When you turn on a VM in the cloud, you're really setting the configuration for that machine right then. And if you turn it off, you can keep the disk around, the boot disk, and then you can just turn it back on with a completely different configuration. So you can be like, oh, I've got a 2-core machine, or now I've got a 25-core machine, or a 250-core machine. And maybe I only want that for like an hour or a day. And that kind of thinking gives you a bunch of flexibility to be able to respond to peak loads, to do reports or whatever that need a big crunch at the end of the month, whatever it is, without building a lot more complexity into the system.
Google is a huge company, and we have a large amount of compute power in the data center. So what's possible with this amount of infrastructure?
Yeah, so I think the classic thing that people talk about is scaling out. Right? You've got one service, then you run it on multiple machines, and you can scale out really well. That's true. But also, I think things have snuck up on us a little bit, and the level that you can scale up to has gotten just huge. So, our largest VMs are currently, 416 core machines with 12 terabytes of memory, large disks and that sort of thing. And so the limit that you can scale a given machine up to, like maybe a database, is quite high. And if you do keep it to one machine, you simplify things a bit. I was shopping for hard disks recently, and the largest one I could find was like 14 terabytes. So you can get a machine with almost that much memory as you'd normally just buy it for disks. So
yeah.
There's plenty of room to scale up as well. And for apps that have been around for a while, scaling out could mean a whole re-architecture. Or scaling up, you can just turn a dial. And it can really help solve a lot of problems and save time and money.
Why does scale up actually matter in this case?
So some of the concrete examples are like a database, which can get really complex when you start trying to shard it and that sort of thing. Another common use case for the really big machines is things like SAP HANA, which is a large in-memory database. It just has to run on one machine. So things like that. I think it gives you more headroom to keep things running that, you don't, it's not the time to do a big re-architecture, for the organization, but it does need to grow with the organization. So you can do that more easily.
So you mentioned VM reboots. How fast is that actually on Google Cloud?
Yeah, it's actually pretty quick. So we can start a machine from scratch, boot the OS, get to your code running in 20 to 30 seconds. So for a lot of situations, that is plenty fast. And that's from nothing. There's no planning, no talking to another team or whatever for provisioning. It's just ready to go.
I've worked with VMs before, and that usually involved, deploying a hypervisor and deploying the VM on VirtualBox or VMware, for example. A lot of steps that can occur. So is it easier here in this case, or?
Yeah, I think the main thing is not worrying about management of all of the machines underneath, right? So you actually don't have to worry about the Tetris game of trying to fit your VMs in with the right other VMs, or whether you have space for them, that sort of thing. That still happens, but it all happens in the back end. You don't have to worry about it.
All right, so what does this all mean practically?
You can make the machine that's exactly the right shape for your workload and not leave idle machines running, and because they cost money. So you can actually make it the right shape. And the other place this plays out is when you're running all your own stuff, you're always trying to keep the most utilization of the hardware you can, because you paid for it, you want to use it, right? And if you can make a machine that is exactly the right shape for your workload, you automatically get the right utilization. And in fact, we'll even recommend, oh, hey, this machine isn't getting as much use as it could be. You might want to make it smaller, or vice versa. It seems to be slammed. Maybe it needs to be a little bit bigger.
Yeah.
That sort of thing.
Yeah, you're kind of moving away from the mental model of how do I make the most use of this box that I've already deployed and procured and paid for versus, okay, I've deployed it, but I can actually backtrack and redeploy using a different shape so I can optimize for the CPU utilization and memory, all these other things. Yeah.
And that's true both at kind of the planning. You don't have to overcommit, early on in a project. But I think, again, where it's not so obvious is the timescales can be short too. So you can reboot it and run it for an hour in the bigger shape, or a certain time of the month, or what have you.
So we talked about scale up. What about scale out cases?
Yeah, this is the classic sweet spot for cloud, right? Where you have multiple computers cooperating to do things, right? And so we have tools built in to Compute Engine to help you scale up and down. There's a thing called Managed Instance Groups that connects to a load balancer, and you can either automatically or on your config decide how many machines are actually behind that load balancer. So it can be 1 or it can be 20, and that can automatically scale up or down, or be on a dial. You basically call an API for how big or small you want it to be. In addition to that, there's cases where you want to be doing kind of batch workloads, or where those machines don't all have to be running that much. And it really helps us out for planning if we can kind of schedule things. So we offer a very large discount on machines that don't live that long. And they're called preemptible VMs. So basically, these VMs can never live more than 24 hours per machine, but they get 80% discount in many cases.
Wow.
So you can be looking at, a fifth the cost of another thing. So if you've got a batch workload, or if you've got a system with very little state on the particular worker machines, you can save a lot of money that way.
Let's talk about access to the VMs. So previously, I remember having to SSH into VMs or RDP into a Windows machine, and then I'd have to save my session login info and target the public IP address of the VM. So, there are multiple steps, and it wasn't always straightforward.
Yep.
But is this the same with Google Cloud? Are there easier ways to access your VMs here?
Yeah, or maybe you create a jump box that's behind the firewall you VPN into, or something like that, right? So, if you need to, you can still do all of those things, right? It's very flexible. And if you've got processes in place, you can keep doing them. But we also have a couple of tools to make things easier than that. So when you're using the web console, you're already logged in and authenticated with Google. So you've got a user, we know who you are, and that you have access to that project. So there's actually a web-based command line console that you can just click a button on any VM, and it will send an SSH key back and forth, and you can log right in.
Nice.
So that's super handy for one-off situations, or emergency things, or on a tablet when you're out or whatever. On the other hand, there's a strong need in large organizations to keep careful track of who's allowed to log in where, and automate that and that sort of thing. And there's a system called OS Login that basically delegates the who's allowed part of it into the overall permission structure of Google Cloud, which is called IAM.
Gotcha.
And so you can basically delegate that there. So users can pick their own SSH key, but the central group can decide who's actually allowed to log into which boxes with that key.
Is this kind of making it easier for administrators who are always trying to manage public-private key pairings and sharing it out with their teams? And how does it make it a little bit easier?
I mean, you can just avoid a bunch of, potential mistakes, or just kind of grunt work of, dealing with all of those.
Yeah.
And I think on top of that, you can audit it better. You can tell exactly what the current configuration is, or you can change it on the fly.
All right, let's talk about disks. So when I think of disks, I imagine you have a boot volume, you have additional volumes for more storage. Is that how they work on Google Cloud too, or different in this case?
This is another example of yes and more, right?
Yes,
so
and.
Yes and. So your model's right. You've got these disks that you can attach or detach between multiple machines. But they are, again, a slice of a data center. So the disks are actually, by default, they're network attached storage, but they're not attached to some particular machine out there. They're attached to hundreds or thousands of machines to get the data back. So you get very consistent performance. You get a lot of flexibility to change things very quickly. And it enables features like if your disk fills up, you can just make it bigger. It also enables things that are really not obvious. So normally, a disk is in a particular physical location. And since these are already spread out, we've got a mode where we actually spread the blocks across 2 zones or across a whole region. And so you can have what looks like one disk to the VM actually living in 2 physical locations. So you get a whole bunch of disaster recovery, kind of crisis mitigation without actually changing the app at all. Essentially what you get is kind of the 80/20 of a SAN, right? You get like a lot of the features you want out of a SAN-based disk, but in the cloud. The other thing that I think is maybe not so obvious is that we think of a computer as this physical box, but in our cloud VMs, the disk is really the kind of identity, right? A boot disk has the operating system and all your software on it and everything. And the computer part is just what happens to be configured currently. So when you turn it off, that part all goes away. And when you turn it back on, we give you a new computer off the same disk. So that changes the way you think about reliability, resiliency, flexibility, that sort of thing.
Yeah, so you can have persistent storage for whatever operating system and files that you already have on that. And then if you decide that you want to reboot and you want to reshape your VM, for example, then you still have everything persisting there.
So that's how it works. What we were talking about earlier. It's because that disk lives on past the config.
This all sounds great, but are there any gotchas or any kind of caveats here that we should be aware of?
Of course. There's always trade-offs in the world, right, of tech. And I think one of the things that's, not super obvious is that everybody wants to use disks differently in the cloud. Some people have tons of storage. Some people want really high throughput. And the way we balance all of that out is by actually connecting, kind of like on a real disk, the throughput to the size of the disk. And it's not obvious. We don't think about it that way when we buy a real disk, but there's a certain amount of storage and a certain amount of I/O that you get when you buy one of them.
Right.
And so we kind of extend that out through the whole platform. So one of the things that can be a gotcha is you go to do a performance test. And you pick a small disk because you're just doing a test, right? And it doesn't work that well. You're like, what? This thing sucks.
Yeah.
And it's important to kind of look at the docs and pick the right size disk for your throughput target. The short version is that larger disks are faster, and they are a network disk, so that uses a certain amount of the network, which also uses some of the CPU. So the number of CPUs kind of affects how the overall throughput and the size the disk does. So take a look at those docs and make sure that you size it right for the workload you're trying to get.
Let's talk about a scenario where you want to take a snapshot of VM for disaster recovery or any other use case related to that. Is it different on Google Cloud? Because I imagine, you still have to take a snapshot. What can it enable you to actually do?
So this is where them being network attached storage is huge. Because we can take a snapshot without hardly affecting the actual usage of the disk at all. And that snapshot can be used to make a new disk anywhere in the world, globally in the same system. So if you're just trying to do straight backups, or you want to make another copy of it somewhere else for kind of reliability, redundancy reasons, that's really straightforward. Additionally, if you're trying to build a full-on disaster recovery situation, it might make sense to think about the overall system a little differently. It may make sense to have the database online and doing kind of a database level replication, maybe to a smaller instance. And then the rest of the system may be behind one of these autoscaling groups where it only gets bigger to full size when it's actually running. And this sort of thing is something we, I've talked to a couple of folks about. Like they are thinking, oh, I want to do disaster recovery in the cloud. We have 25 machines running the full thing, in our site or in another zone.
Yeah.
We need 25 machines for the disaster recovery site. And it's the obvious kind of straightforward way to think about it, model it. But likely you probably only need 1 or 2 machines running all the time. And the rest of them, you can take advantage of the flexibility and actually just make them exist, when you actually have a disaster.
Yeah, and if that were to occur, I'd imagine that there is a pretty fast ability for it to become active.
Yep. So it's the same thing we were talking about earlier where, the individual machines are up in 20, 30 seconds and they're behind the same load balancer. And so they just kind of scale up to deal with the new traffic.
All right, so we talked about a lot of things. VMs, we talked about load balancers, disks.
Yep.
Rethinking VMs entirely. What can people do to get value out of cloud right now?
Yeah, that's in fact the reason I'm excited about this, because VMs are almost always like the next step for people who are getting into cloud. It's closest to the architectures they currently have. You can run almost any software there. So they're the next step. And if you're building up that architecture, it really helps to kind of dig a little deeper on these, because you can simplify or maybe leave whole parts of it out and still get the same reliability or more and more flexibility out of it. So that's where the saving time and money comes in. So I really encourage people to go kind of take a look at the architectures they're thinking about and connect them to the features we have to simplify them and see where you can save some time and money.
Awesome. Well, that's great words to end on. And also, I want to thank you for coming back on the show, because I think you have so much good insight into just shifting your mental model of how to think about cloud and VMs. So thanks again, everyone. Again, please join us next time for Eyes on Enterprise, and we'll see you again soon.